Okay, do you have any doubt regarding yesterday class?
I just have a question, sir.
Yes.
In glycolysis, uh,
Mhm.
glucose is converted to fructose 1,6B biphosphate, right? So is this fructose same as the fructose that we get from fruits?
No, it's different. That is only fructose. Here it is fructose 1,6 biphosphate.
Okay,
They are
okay,
having different structure. Yes.
okay, thank you.
Okay, so let's have a quick revision. First, I told you there are three steps in which glucose is being broken down, and there is production of energy take place. First step, glycolysis. Where this step take place?
Cell within the cell.
Within the cell. Where?
Cytoplasm, cell cytoplasm.
Cytoplasm. Cytoplasm. And next step is pyruvate oxidation. Pyruvate oxidation. So this step happens in mitochondrial matrix. Third step is Krebs cycle or TCA cycle or citric acid cycle. I told you yesterday why these names are being given to this Krebs cycle. Now these three steps are responsible for production of energy molecule. They can be ATP, they can be NADH, they can be FADH, and they can be GTP. But our body can only use this ATP. So in order to convert all the remaining molecule into ATP, there is fourth step. What was the name of that fourth step?
Oxidative photophosphorylation.
Yeah, oxidative.
Dilation, post.
Yeah, phosphorylation or oxidative photophosphorylation. Okay, so this is the basic outline of what we are studying. We already discussed glycolysis. Uh, so I'm sharing presentation with you. Okay, glycolysis, this is happening in cell cytoplasm. What is happening here? Glucose, which is a six carbon compound. Glucose, which is a six carbon compound. First, it is being converted into fructose 1,6 biphosphate. Two energy molecule are being used here. Means we are using two energy molecule, and then this fructose 1,6 biphosphate was broken down into two molecule. These two molecule are unstable molecule, DHAP and glyceraldehyde 3-phosphate. First, this glyceraldehyde undergoes several chemical reaction, and in these chemical reaction, first there is production of NADH, then there is production of ATP, and there is production of 1 ATP. So as these are two molecule, then again this second molecule DHAP will again be converted into glyceraldehyde 3-phosphate, and again the same cycle happens. So in this cycle, there is utilization of 2 ATP and production of 2 NADH. Why 2 NADH?
From DHAP also.
Yeah, because there is DHAP also, and it also will be converted into glyceraldehyde, and same cycle from here will happen twice. So again, there is production of 4 ATP. 4 ATP production. So this is all about glycolysis. Next, this is actually anaerobic respiration. First step is same for both aerobic and anaerobic, that I will explain later. Okay, second step is pyruvate oxidation. Each pyruvate molecule will react with this coenzyme A, and in this reaction, one carbon molecule will be removed from the reaction, and in this reaction, there will be formation of one NADH. So in this, there is formation of one NADH. But how many pyruvate molecule are being produced from one glucose molecule?
2.
Two pyruvate molecules were there. So this step also happens twice for one glucose molecule. So in actual, there will be production of how many NADH?
2.
Two NADH. Yes, two NADH production will be there, and production of two acetyl coenzyme A. This is very important in order to understand the total number of ATP production in this reaction. So is anyone having doubt in this step why there is two NADH, why there is two acetyl coenzyme A? Is anyone having doubt in this?
Is only because it happens twice, because each molecule is broken down into 3.
Yeah, because glucose is a 6-carbon compound, and from that glucose, two molecule of pyruvate are being produced. Pyruvate is a 3-carbon compound. So we have two molecule of pyruvate, and that two molecule of pyruvate will produce two NADH and two acetyl coenzyme. Next, there is citric acid cycle. So why we are calling this as cycle? Because this process is cycling. This process is cyclic process. I will explain this. So what is happening here? Like first, there is a compound. This compound named as oxaloacetate. Oxaloacetate first react with this acetyl coenzyme. This oxaloacetate is reacting with this acetyl coenzyme A, and in this reaction, one molecule of coenzyme A is being removed from this reaction, and this acetyl coenzyme A and this oxaloacetate are being converted into citrate. They both then formed citrate. Is this step clear to everyone? From here,
Oxaloacetate combines with acetyl coenzyme and then releases coenzyme,
Yeah.
acetyl coenzyme.
No, just coenzyme. Coenzyme will be released, and this acetyl and oxaloacetate will form citrate. This acetyl coenzyme A is the same acetyl coenzyme A which is being produced from this reaction, this pyruvate oxidation.
Okay.
Yeah. This coenzyme A then will enter this Krebs cycle. This one molecule will react with oxaloacetate, and it will form citrate. So
Okay.
then, yeah, then the
So
citrate.
molecules that you have drawn also will be same, like 4 oxaloacetate molecules combine with acetyl coenzyme to give 6 molecules of citrate.
Yeah, 6 molecule of citrate. This circle denote the number of carbon atoms.
Okay, sir.
So 6-carbon molecule, citrate is 6-carbon molecule. We don't need to remember the number of carbon atom in each molecule. We just have to remember number of ATP and NADH production. So this citrate is converted into other molecule, and in this cycle, what happened? There is production of one NADH, production of another NADH, and production of one more NADH. So in this whole cycle, citrate further undergoes various reaction, and citrate from undergoing various chemical reactions, citrate at last again converted into oxaloacetate. So this is 6-carbon compound, and after undergoing various chemical reaction, it becomes 4-carbon compound. So what is the fate of those 2 carbon? Those 2 carbon are being eliminated in the form of carbon dioxide, one in this step and one in this another step. So in this whole cycle, what is happening? There is formation of 3 NADH. There is formation of 1 GTP. And there is formation of 1 FADH. Or we can write it as FADH2. These are the formation in this whole cycle. So after undergoing various steps, this citrate will be converted into oxaloacetate. Now this oxaloacetate is again ready to take up a next molecule of acetyl coenzyme. That's why it's a cyclic process. Because it starts with this oxaloacetate, and this oxaloacetate react with a molecule of acetyl coenzyme A. This forms citrate. After various reactions, this citrate again form oxaloacetate. So that's why this is cyclic process, because first product is the last product of this reaction, and in this cycle every time acetyl coenzyme A is being used. So in one cycle, there is production of 3 NADH, 1 GTP, 1 FADH2. So for one molecule of glucose, how many cycles will be there? Are you getting
A
my question?
molecule of glucose, how many Krebs cycles would be there?
Krebs cycle.
Yeah.
Because there are
Mhm.
2 molecules of coenzyme. So,
Yeah. So 2 cycles will be there.
okay.
Okay, everyone is getting this point. Why for one molecule of glucose there will be 2 Krebs cycle? Because there is production of 2 pyruvate, and of this 2 pyruvate there is production of 2 acetyl coenzyme A, and because there are 2 acetyl coenzyme A, this will enter the cycle 2 times. So this cycle will also happen 2 times for one molecule of glucose. Is it clear?
Yes, sir.
Okay. So now we can also calculate the total number of carbon dioxide produced. One molecule of carbon dioxide is being produced in this pyruvate oxidation. There is production of 1 CO2, but this also happens twice. So totally in this reaction, there will be production of 2 CO2. Now, in this reaction also, 2 carbon dioxide are being produced in a single cycle. But as I told you, this cycle will happen twice. So total number of carbon dioxide produced will be 4 CO2. And this also, total number of NADH, how many NADH will be produced here by one molecule of glucose?
6.
3 into 2 times. Yeah.
7.
6 NADH, 2 GTP, and 2 FADH. So this is total number of energy molecule produced in this reaction. So this is third step, and this step is known as Krebs cycle. What you have to remember here, this is first molecule being produced in this reaction is citrate. This is 6 carbon compound, and after eliminating 2 carbon in the form of carbon dioxide, it becomes oxaloacetate. It is 4 carbon compound. So last and first molecule in this is oxaloacetate. First formed compound is citrate. So this is all about Krebs cycle.
Sir, in the first cycle in glucose to pyruvate, we already have 2
Yeah,
NADH, 2 ATP,
yeah.
4 ATPs. So,
Mhm.
so in Krebs cycle, we have 6 NADH. Will we be adding those
Yeah.
two also?
We will add all those, and then we will calculate how many total energy production is happening there.
Okay.
Okay, so we can write in this. In this, there is production of 2 NADH and 4 ATP. And there is also utilization of 2 ATP. So this is all about metabolism of one glucose molecule. So the acetyl coenzyme A made in last step combines with a 4-carbon molecule and goes through a cycle of reaction, ultimately regenerating again the 4-carbon starting molecule. ATP, NADH2, FADH2 are produced and carbon dioxide is released. So question can be like this: how many molecule of carbon dioxide are evolved from one molecule of glucose? Or it can be like this: how many molecular carbon dioxide are released in a single cycle? So for this, you have to clear your concept. Fourth step is oxidative phosphorylation. This is also known as electron transport chain. And the main enzyme which works in this reaction, the name of that enzyme is ATP synthetase. This enzyme name is not written here. Yeah, ATP synthase. ATP synthase enzyme. With the help of this enzyme, what happens? Our body produce ATP with the help of NADH2, FADH2, and GTP. So with the help of NADH2, our body produce 3 ATP. With the help of FADH2, our body produced 2 ATP, and with the help of GTP, our body produced 1 ATP. And this whole step is known as oxidative phosphorylation or oxidative photophosphorylation or electron transport chain. So this is the only step you have to keep this in mind. This is the only step which use oxygen. Without oxygen, all the previous step can be happen. They don't need the presence of oxygen. Oxygen is only needed in this fourth step, that is oxidative phosphorylation. So now we can calculate the total number of ATP produced from one molecule of glucose. So from this 6 NADH, how many total number of ATP will be produced? One molecule of NADH produced
12. Two
three.
12.
Yeah, one molecule of NADH produce 3 ATP. So 6 NADH will produce 10 ATP. 2 GTP will produce 2 ATP. And 2 FADH will produce 4 ATP.
12.
Now let's come to this step. In this production of 2 NADH is taking place. So total ATP will be 6 ATP. In the first step, there will be production of 2 NADH. 2 NADH means 6 ATP and 4 ATP was already there. So how many total number of ATPs are producing in this reaction? You can add all these.
10.
Yeah, in all reaction. So you have this 40 ATP. 40 ATP are being produced from all the 3 reactions. If you add all these, there will be production of 40 ATP. But there is one more thing. 2 ATP are also being utilized here. 2 ATP are being utilized. So if we talk about how many total or net ATP production. So net ATP production will be 38 ATP. So from one glucose molecule, there will be production of 38 ATP. Is it clear to everyone?
Sir, I didn't understand the last few minutes of your lecture because I couldn't calculate how you were getting into all those things.
Okay, we can do it here. In glycolysis, how many ATP are being produced from one molecule of glucose?
6.
6
That is,
ATP.
out of 2 NADH molecules, we are getting
6 ATP we are getting from 2 NADH molecule, and
and
4
4 ATP.
ATP were already there. So 10 ATP are producing from glycolysis. Out of this 10 ATP,
Sir, one more question. If you go back to the diagram of glycolysis,
Mhm.
there, when you showed the sequence, the NADH molecule, there were only 2 ATPs produced, right, in one cycle.
Yes.
So when it happens for 2 times, because there are 2 molecules, it generates 4 ATPs.
Yeah.
Right?
Yeah.
But again, this NADH in the diagram, you're not showing that it is producing ATP.
It producing ATP. NADH production is there now. From one molecule, one NADH production is there. So from 2 molecules, there will be production of 2 NADH.
Yes.
And these 2 NADH will produce 6 ATP.
So, one molecule of NADH produces 3 molecules of ATP.
Yes. It is written here. First, you have to remember this. One NADH produce 3 ATP. One FADH2 produce 2 ATP. One GTP produce 1 ATP. So because 2 NADH were there, so they will produce 6 ATP.
Yeah.
Okay, so in glycolysis, there is production of 2 NADH and production of 4 ATP. So these 2 NADH will produce 6 ATP and total number of ATP will be 10. But in glycolysis, we have also utilized 2 ATP in the first step. Are you getting this?
Yes.
Okay. 2 ATP we are utilizing in first step. So net gain of ATP will be 8 ATP from glycolysis. Is it clear to everyone? We can also go back more time if you are having doubt in this. Okay, so next step is pyruvate oxidation. How many NADH are being produced from one molecule of pyruvate? There is production of one NADH. But as there are 2 pyruvate molecule from one glucose molecule, then there will be production of 2 NADH. Is it clear? Then there will be production of 6 ATP. So from pyruvate oxidation, there is net production of 6 ATP. Now let's us talk about Krebs cycle. So from one molecule of acetyl coenzyme, how many NADH are being produced there? Just from one molecule.
3 NADH.
3 NADH. And
Above NADH, also the ones which are produced in pyruvate oxidation also get added to this.
sorry.
Here in the Krebs cycle, from the diagram, there are 3 There are three NADH molecules. The
NADH
ones that get produced in the pyruvate oxidation,
that is different.
okay, they don't get added anywhere here.
Okay, we just calculate that in pyruvate oxidation.
Okay, so this we have to consider it from the beginning. So the Krebs cycle produces three NADH molecules.
Krebs cycle three
And
NADH.
those three NADH molecules will produce
How many ATP?
nine.
Yeah, 9 ATP. And 2 FADH were also there. So it will produce 4 ATP and 1 GTP is there.
1 ATP.
1 ATP. But we have 2 molecule of acetyl coenzyme A from 1 molecule of glucose. So this cycle will happen twice, and all these ATP are produced in double amount. Is this clear to everyone?
28.
Yeah, 28 ATP.
Yes, sir.
So
From the glycolysis step, we have 8. From the pyruvate oxidation step, we have 6, which is 14. And from the Krebs cycle, we have 14 again.
yeah,
Okay.
so total number of ATP will be
28 because we have 2 cycles going on. That's why we have 28 plus 28. 42.
not 28 plus 28. Actually, 3 NADH, 2 FADH, and 1 GTP. This is produced in one cycle. So if we go to
FADH is just one.
yeah, in one cycle there is production of only 14 ATP. If we
12.
add,
12. FADH is only one in one cycle.
sorry, so there will be production of okay, just
One FADH.
Only one FADH is produced in one Krebs cycle, right? So to
Yeah,
both
yeah.
the Krebs cycle, if we consider 2 Krebs cycles, then there will be a production of 4 ATPs, but here it's only 2 ATP.
Yeah, then there will be total 12 ATP production. That's what I was looking for, why the ATP number increased suddenly.
So it is 24. 24 ATP for
4 ATP from Krebs cycle, 24 plus 6, 30 ATP from both this pyruvate oxidation and Krebs cycle, and 38 ATP production will be net ATP production from glycolysis, pyruvate oxidation, and Krebs cycle. So the net ATP production, if you have question, net ATP production from one molecule of glucose, then it will be, yes,
Be 38 ATP from
one molecule of
one
glucose.
molecule of glucose. Yeah.
So there is one more thing you will find in many books. The net ATP production is 36 ATP. You will find in many books, and in many books you will find 38 ATP. If you get this question in exam, this option will be correct. But why some books write this 36 ATP? Can anyone tell this?
Molecules of ATP are used in the cycle, in the first cycle.
That are already being subtracted. No? That's why there are 38, not 40. It is because no machine is perfect. Every time there is some loss from every machine, whether it is car engine, whether it is mobile, every machine is prone to some loss. So there should be net production of 38 ATP, but some scientists consider that 2 ATP are being lost because of some machinery problem, because of some waste of ATP. So net ATP in theory, net ATP production should be 38 ATP, but in practical, some ATP are being lost in some step, so there is production of 36 ATP. Is it clear? Okay. So this is all about anaerobic respiration. Now, what happens in anaerobic respiration? Aerobic respiration in which our body has oxygen, in which our body has enough amount of oxygen to carry out this last step. Now, what if our body don't have oxygen? When this condition is produced in our body, when anaerobic respiration will happen in our body, we have respiratory system, but still we are some condition in which we are lacking oxygen.
Kinds of respiratory diseases, or because of excess exertion.
Yeah, because of excess exertion or physical exercise. Physical exercise, your body needs very much energy, your body needs very much oxygen to break down glucose, but that oxygen supply is not optimum. That's why in yoga, the pranayama is given very much importance, because there are two things. First one is fuel, another one is oxygen. Everyone has fuel in their body, in the form of fat, in the form of carbohydrate. We are having our meal 3 times a day: breakfast, lunch, dinner. Everyone is focusing on this fuel, but in yoga we also focus on this oxygen. We have to increase our oxygen capacity, we have to increase our various lung capacities, so that oxygen is also keep remain in our body, even in the episodes of some exertion, even in heavy physical exercises. Respiratory system is completed in your anatomy.
Sir.
Yeah, there are various lung capacity, like inspiratory capacity, expiratory capacity, tidal volume.
We completed respiratory system is completed.
Yeah, so all these capacity, I think you know about. Tidal volume.
Tidal volume, yes.
Yeah.
Residual volume.
So in yoga, especially yogic breathing aims to increase our tidal volume, aims to increase our inspiratory capacity. The more our inspiratory capacity will increase, the more our respiratory capacity will increase, the less our body goes in this anaerobic respiration phase. This respiration only occur when our respiratory system is not that much capable to provide enough amount of oxygen that required during physical exercise. So during physical exercise, when we need very much energy, so to give that energy, our body need fuel plus oxygen. Fuel is present in our body in the form of glucose, but oxygen becomes limitation factor here. So in this limitation of oxygen, our body carried out anaerobic respiration. So what happens in this anaerobic respiration? First step is same. This step, glycolysis, is same. This is first step of anaerobic respiration. In this step, 2 ATP will be used, and there will be production of 4 ATP, and there will be production of 2 NADH. So now, as I told you, 2 NADH are being converted into ATP in which step?
Fourth step, oxidative.
Fourth step, yes, oxidative phosphorylation. But that step needs oxygen. And in this condition, our body don't have enough oxygen. Then what will happen? The next step happens only to degrade this NADH, because what happens with accumulation of NADH, as I told you earlier, if our body is not utilizing this NADH, if fourth step is not happening and body is producing so much amount of NADH, then it will become toxic for body and it can be fatal condition. So the next step, there is no production of energy. There is just utilization of these 2 NADH without oxygen. So next step is known as lactic acid production or fermentation. Okay, I will write it here. From one molecule of glucose, your body produced 2 pyruvate. And in this 4 ATP production was there. In this 4 ATP production will be there. In this 2 NADH production will be there. And 2 ATP consumption will be there. This is first step. So second step is just to utilize this NADH so that it won't get accumulated in absence of oxygen. So second step is different in humans and microorganism. We will discuss both of them. What happens in human? This pyruvate is converted into lactic acid. And in this process, 2 NADH are used. Sorry, 1 NADH is used. Similarly, what happens in microorganism? This pyruvate, like yeast and all, alcohol. Which alcohol? That alcohol is ethanol. In this reaction, also 1 NADH is used. So as there are 2 pyruvate molecules from 1 molecule of glucose, then there will be 2 NADH. And in this also, there will be 2 NADH consumption. 2 pyruvate molecule were there. Again, I will explain. From glucose, our body was producing 4 ATP, 2 NADH, 2 ATP, and 2 pyruvate molecule. But in this condition, our body don't have access to oxygen, so our body can't use these 2 NADH. So our body has to fix these NADH anywhere, else it would be accumulated in our body and it would be toxic for us. So what our body does, our body just convert this pyruvate into lactic acid, and for this process, our body utilize these 2 NADH. In yeast, what happened? These 2 molecules of pyruvate are converted into alcohol, ethanol, and for this also 2 NADH are also needed. So this NADH which were get produced in glycolysis are now used. So what is net production of ATP in anaerobic respiration?
0.
2 ATP.
How is it 2 ATP?
2 ATP because NADH we used in next step. Now in glycolysis, we only have 4 ATP production and 2 ATP consumption. So net ATP will be 2 ATP.
Yeah.
This glycolysis also comes under anaerobic respiration. First step, and this is second step. Glycolysis is common in both anaerobic and aerobic respiration.
Right.
Okay,
So
now
here we produce 8 ATPs, right, sir?
8 ATPs production should be there. Can you repeat your question?
In glycolysis, both anaerobic and aerobic, there will be 8 ATP production.
8 ATP production only happens if these two NADH will be used in oxidative phosphorylation. Then only 6 ATP production will be happen from these two NADH. But in this anaerobic respiration, we are not capable to use these two NADH because we don't have oxygen. Our body use these two NADH in producing lactic acid, and in yeast, these two NADH are used in producing oxygen. So no ATP are
4
being
ATP molecules which get into the reaction, those 4 ATP molecules, 2 are used and 2 are left.
Yeah. 2 ATP we are already using in glycolysis now.
Yes.
Okay. In summary, we can say that 4 ATP production, 2 NADH production, and 4 ATP and 2 NADH production is there. Out of which, in anaerobic respiration, we are using 2 NADH, so it won't get counted. And 2 ATP are already we are using in glycolysis, so there will be only net gain of 2 ATP.
Yeah.
So now you can correlate that how many differences in ATP when there is oxygen and when there is in aerobic respiration. Our body is producing 38 ATP theoretically, and in anaerobic respiration, our body is only producing 2 ATP, and plus this lactic acid. What will be happen to this lactic acid?
Stored in the muscle.
Yeah, this lactic acid got accumulated in the muscles and it caused pain. After some time, this lactic acid will be get absorbed by blood vessels. That's why it is recommended to have massage when there is lactic acid accumulation, because with massage, this lactic acid will be easily absorbed in blood vessels and our liver extract this lactic acid from that blood and release it into our digestive system to get it out of the body. So because of this lactic acid production in our muscle, we face cramps. In yeast, what happens with this alcohol? This alcohol is no use for yeast, but it is very much useful for humans. This is the principal step in formation of alcohol from yeast. Okay, so that's why there is very much importance given to pranayama, because the much we have our oxygen capacity, the much we have respiratory capacity, the much our body will go in aerobic respiration, not in anaerobic respiration. So we are having 36 more ATP in aerobic respiration than in anaerobic respiration. So this question is also once asked in UGC, like how many more ATP are being produced in aerobic respiration as compared to anaerobic respiration. So I think all of this is clear to you. Any doubt regarding this? Okay. Okay, one more thing, the production of ethanol from pyruvate is known as fermentation. And the production of lactic acid from pyruvate, which happening in our body, that is known as lactic acid formation or lactic acid fermentation. So these are two aerobic and anaerobic respiration. This is lactic acid fermentation. Our body is producing 2 NADH from one molecule of glucose in glycolysis. This is glycolysis. And in next step, our body is using these 2 NADH. Why our body is using these 2 NADH?
Accumulation of NADH is
Because if our body will not use this NADH, these NADH will be accumulated because we don't have access to oxygen. Our body can't undergo through fourth step, that is oxidative phosphorylation. So anyhow, our body have to use these 2 NADH, and for this, our body convert this 2 pyruvate into lactic acid. Okay, these are two important terms.
Lactic acid, what is that? Two lactate.
Yeah, lactic acid is also known as lactate. From one pyruvate, there is formation of one lactic acid or lactate. From 2 pyruvate, there is production of 2 lactate or lactic acid. Okay, fate of excess glucose. This we already discussed. That is what is glycogenesis. We already discussed this after about 150 gram of glycogen is stored in muscle, and this amount can be increased five-fold with physical training. The glycogen stored in human liver is about 90 gram. So overall, I have told you it's around 600 grams. Our body can accumulate that glycogen. After that, what happened to that glycogen?
Converted into fat.
Yeah, converted into fat. This gluconeogenesis we also discussed in previous classes, like it is formation of glucose from non-carbohydrate substrate. Okay, this gluconeogenesis, as I told you, this is also known as neoglucogenesis. Okay, now let's talk about recommended dietary allowance, RDA. How much carbohydrate we should consume. So there is no any specific recommendation of consumption of carbohydrate, but if your diet, if you are taking some diet, then 60% of that diet, 60% of that diet should comes from carbohydrate. So if you are having 2000 kilocalorie diet, then 275 to 300 gram of carbohydrate is recommended. So out of this 60%, like 60% of our diet should be carbohydrate. Out of this 60%, only up to 10% should be from monosaccharide or disaccharide. Rest 50% should be polysaccharide. So in many books, you will find 50 to 60%. In many books, you will find 40 to 60%. And in many books, you will find just 60%. So this is average requirement of carbohydrate. Why this much carbohydrate?
ATP is produced from carbohydrate, and that's the basic energy source.
Yeah, and that is basic nutrient required for energy production. Okay, so this is all about carbohydrate. Please go through this slide. I have already shared this slide in group. Please go through this slide. Please complete whole of this carbohydrate, including that first slide and including this slide also. If you are having doubt, then we will take the doubt in next class. In next class, first 5 minutes, we will only discuss doubts on carbohydrate. So till tomorrow, please complete these two PPTs so that we can discuss your doubt if you are having any doubt.
So I just have a question from where, on what basis this was calculated? 10% of carbohydrate should be from monosaccharide or disaccharide.